Acha, before discussing momentum, let me discuss about the kinetic energy. Kinetic energy, you know that. What is kinetic energy? The energy possessed by a body due to its motion. And how we can find out the kinetic energy? If you have a body of mass m and that body of mass m is moving with the velocity v, say this v is the velocity of the body, so we can find out the kinetic energy, half m v square. Okay, so kinetic energy is scalar or vector? Energies, whatever the type of energy is, whether it is potential energy, kinetic energy, heat energy, etc. If there is a type of energy, energy is a scalar quantity, not a vector quantity. You must keep in your mind. Yes, G. As far as the velocity is concerned, now she says, because many of you are saying that velocity is a vector quantity, and you can say that velocity is the part of this formula of kinetic energy, so kinetic energy must be a vector quantity. No. Why it is not a vector quantity? Because it is the energy possessed by a body. Whenever the body is possessing an energy in it, that energy don't have any direction. That energy is possessed within the body. This energy is irrespective of any direction. We are not considering the direction of energy. We only say that this body is possessing some energy. As for the definition of the kinetic energy is concerned, this is also telling you that energy possessed by a body. When you are using the word possessed by a body, it means that energy is within the body. So the body is possessing the energy, it don't have any direction. What makes the direction? The motion makes the direction. The motion makes the direction. Now here, momentum, I told you that momentum is the quantity of motion in a body. We say quantity of motion of the body, and it can be calculated by multiplying mass and velocity. If I say that momentum is represented by P, so m for mass, mass of the body, and into the velocity of the body. When we are multiplying these two, so this is making the formula for momentum. It has direction. So remember this, this is a vector quantity. Now you will say that here is also velocity is used, that is also velocity used, that why it is a vector quantity, mass and velocity, both the same variables are using. Both the quantities, mass and velocity, are used here. Here again, I am using mass and velocity, but that is a scalar quantity, it is a vector quantity. When there is a motion, remember this, when we are talking about the quantity of motion, here we were talking about the energy possessed by a body, but here we are talking about the quantity of motion in a body. So if the word motion is discussed, that the body is, that quantity of motion is in the direction, when there is a motion, it will obviously have a direction. So that's why it is a vector quantity. What is the unit of momentum? The unit for mass is kg. Kg, meter per second, because the velocity is measured in meter per second and mass is measured in kg. So the unit of this is kg, meter per second. Clear? Okay. Now conservation of the linear momentum. Now here, when we are talking about conservation of the linear momentum, so we will say that there is an isolated system. We have to consider that there is an isolated system. If I am talking about an isolated system, what does it mean? It means no energy can come in the system and no energy can go out of the system. Okay? So you must keep in your mind that if I am talking about a system, then that system which is consisting of two or more than two bodies, so we have to consider that no energy losses are there. There is no energy loss. Okay? So this fact must be kept in your mind, but practically there is a different situation. You can see that if we can hardly have an isolated system, you can see the energy is wasted in an environment, etc. So here we are talking about an isolated system in which no energy, neither energy lost, no energy gained within the system. Okay, momentum of a system, momentum of an isolated system remains constant, that in an isolated system, the total momentum remains the same. Let us consider two bodies. One is having mass m1 Let us consider two bodies. The body M1, the mass of this body, say it is 400 kg. This is the body of 400 kg. Its initial velocity is u1. Say the initial velocity is 5 meter per second. Its initial velocity is 5 meter per second. There is another body. Say its mass M2. It is 100 kg. It is 100 kg. Its initial velocity u2 is equal to 0. For the sake of convenience, I am using different variables like u1 because m1 is the mass of this body, u1 is the mass of the velocity of this body, m2 is the mass of this, and u2 is the velocity of this. This body is moving with 5 meter per second, and this body is not moving, it is stationary, it is not moving. Clear? So this body is moving towards this with this velocity of 5 meter per second. What will happen? Will it collide or not? When this body, which is moving at 5 meter per second, it will collide with this body, what will happen? What about the speed of this body? Will it decrease? It will decrease. When it will collide with this body, the speed of this body will decrease and this body will come into motion with certain velocity. Now let us consider, say now after collision. Yes, it is an isolated system. I told you that I am talking about an isolated system. After collision, what is happening? This body, which is having the mass m1, the mass remains the same. Its velocity becomes u1. We have to find out this velocity. After the collision, we have to find out the velocity of this body. While this body is moving, this m2 is moving with velocity v2, say it is 4 meter per second. When this body strikes with this body, after the collision, this body will have certain velocity. We have to find out this velocity. But we have to find out that what will be the velocity of this body after the collision. Okay? So what should we do? To find out the velocity of this body after the collision, we have to do the working according to the law of conservation of linear momentum. We have to do the working. As I told you, in the case of the law of conservation of momentum, that the momentum before the collision must be equal to momentum after the collision. I told you according to this law. Clear? So let us calculate the momentum before the collision. So that collision, that momentum is depending upon the momentum of this body m1 and momentum of body m2. So first of all, let us calculate the momentum before the collision. So that will be the mass into velocity. As I told you, the momentum formula is mass into velocity. So the mass of this body is m1 and the velocity of this body is u1. So its momentum before the collision is 400 multiply 5. This is the momentum of this body plus the momentum of this body. 100 multiply what? 0. Okay. So this is the moment before the collision, by multiplying each mass with its respective velocity. The momentum before the collision. This body is moving with 5 meter per second velocity, so multiply the mass and velocity plus the momentum of this body. So here you can find out 5 4s are 20, 2000 plus 0. Okay. Now here, as I told you, according to the law of conservation of momentum, the momentum before the collision must be equal to momentum after the collision. So find out the momentum. V1 into 400 mean 400 V1 plus 100 into 4, because the velocity of this body becomes 4 meter per second after the collision, as these values are given. This will be equal to 400 V1 is equal to 400, sorry क्या हो रहा है यार, प्लस 400. ठीक है जी, ये this is the momentum before collision, this is the momentum after collision. अब इसको सॉल्व कर लें जी, बताइए. This 400 will be subtracted to the other side. This is 1600 is equal to 400 V1. So V1 is equal to 1600 over 4. So answer is 4 meter per second. So this is the velocity of the second body after the collision. Clear? So this is basically the application of the law of conservation of momentum.